So in this video, let's look at the unit circle. If we were to be given an angle, how can we find where it lies on the unit circle? Is there an easy way to figure this out without just memorizing the whole circle? This will be very helpful as we approach finding certain trig values like the sine or the cosine of particular angles. We need to know where that angle lies on the unit circle. And I want to stick to some of our basic angles, which would be our 30 degree, 45 degree, 60 degree, and 90 degree angles. So let's first look at the angles that lie on the x and y axis. So here at the unit circle, at our standard position right here to the right, the positive x-axis, that's 0 degrees. If you make a whole circle, that's also a 2 pi. Right? They kind of represent the same thing. So at 0 degrees, if you think about this, the unit circle, if you start at 0, 0, and you were actually going to plot a point right here on the unit circle, you would go over 1 and then up 0. We call it the unit circle, so you go over 1 unit. So you have the point 0, 1, 0. Okay, a little trick to know that the first number in that point, which is the 1, always represents the cosine. The second represents the sine. That's very handy to know. So in this case, the cosine of 0 degrees is 1. The sine is 0. Okay, now let's look at the positive y-axis at 90 degrees. We have pi over 2. And if you notice this point, starting at 0, 0, you went over 0 and up 1. Like I said, we have cosine, sine. Okay, if you go half of a circle, that's pi. To get to this point, you had to go over -1. That would be what? Cosine. And up 0. Okay, so the cosine of pi is -1. The sine of pi is 0. And then lastly, we have 3 pi over 2 down here. And then, of course, you went over 0 and down 1. That represents cosine, sine. Okay, these are basic angles on the xy axis. These are very handy. If you think about it in terms of the unit circle, you can find sine and cosine very easily by plotting these points. And remember the way that we can actually find these angles, if we started at 0, if we go pi over 2, let's see, we had 0, and then we go pi over 2, so that's 1 pi over 2. If we go here, this is pi, which is 2 pi over 2, and then 3 pi over 2, and then of course if you went the whole circle, you would get 4 pi over 2, which is 2 pi. So just you can remember 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Okay, I want to look at our first set of angles that all relate to pi over 6, which is our 30 degree angle. So let's draw it on the unit circle. A 30 degree angle right here, 30 degrees, is the same as pi over 6. Okay, so we have 4 angles that we want to talk about that have something in common with 11 pi over 6. So that's our first one, pi over 6. This is in our first quadrant. It's also called our reference angle. That's quadrant 1. So if we move over to quadrant 2, if we have the number, the angle 5 pi over 6, how do we come up with that? Well, for quadrant 2, if we move half the circle over to pi, remember pi, right? Pi can be written, it's the same as 6 pi over 6. So if I want to find this angle right here, basically we could go over to pi, right? And it's a little bit smaller, so we're going to subtract off a pi over 6, right? Because this clearly is, you can look at the two angles and they both have the measure of pi over 6 as far as the distance. So we took pi minus pi over 6, that's taking away 1 pi over 6, that gives you 5 pi over 6. Okay, that's this angle. This is quadrant 2. The quick way I remember is if you have the angle is over 6, quadrant 2, the numerator is just 1 less, 5 pi over 6. Now if we go to quadrant 3, the way we find that is we can go to pi, right? And if we add a pi over 6, right, because we've gone a little bit further. Now remember, if you start at your standard position, you basically have gone a whole half, which is a pi, plus an additional pi over 6. So pi plus pi over 6 gives you 7 pi over 6. Okay, so in quadrant 3, you can just remember the numerator is 1 more than the denominator. Okay, and for our last angle, we're going to look in quadrant 4. Okay, to get to this one, the way we would find it is we could go a whole rotation. Remember, if you go a whole rotation, that's the same thing as 2 pi. So to find this one, we can take a whole rotation, 2 pi. Right, and we're going to subtract off, because it's not quite a whole rotation, so we'll subtract a pi over 6. If you do that, let's see, 2 pi, you can convert that to 12 pi over 6 minus 1 pi. That gives you 11 pi over 6. So this angle is also known as 11 pi over 6. Okay, so these are our 4 angles we want to look at. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So you notice we've got quad 1, quad 2, 3, and 4. So let me just remind you what we were talking about for the first angle. That's just our reference angle, pi over 6. For quadrant 2, the quick way of finding it is you can just know that the numerator is 1 less than the denominator, 5 pi over 6. For quadrant 3, the numerator is 1 more, 7 pi over 6. And for quadrant 4, it's not quite as easy to remember, but a quick way to do this is you can double your denominator, get 12, and take away 1. So if you double 6, you get 12, take away 1. So these are our 4 angles. Okay, so if you look at those, what do these 4 angles have in common? They're all over 6. The reference angle for each of these, all 4 of these, we call a reference angle, is pi over 6. The reference angle is going to be important when we find trig values. So we need to know where the angle lies on the unit circle. We also need to know the reference angle. Okay, so let's look at these. For pi over 6, we clearly just went pi over 6. For our 5 pi over 6, if you go over to pi, we basically subtracted pi over 6, but we went a distance with pi over 6. 7 pi over 6, it still has the same angle. You can look at it and tell they're the same. It's pi over 6, and then same thing for our quadrant 4, pi over 6. The reference angles, you can look and tell they're reflected across the x and y axis. So let me shade them. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. You can look at it and tell what the reference angles are. Okay, now let's look at 4 more angles, all with respect to pi over 4. So in the first quadrant, this 45-degree angle is also known as pi over 4. Okay, and there are 3 more angles, just like the last time, that have a similar reference angle to pi over 4. That would be pi over 4. Right, this would be 3 pi over 4. So remember how we get 3 pi over 4. We can come over to pi, right? And we know quadrant 2 angles. Let's see, pi is the same thing. Since everything's in terms of the denominator 4, you could rewrite pi as 4 pi over 4. 4 pi over 4. So in quadrant 2, the angle is 1 less in the numerator. That would make it, let's see, 3 pi over 4. 1 less. Right there. Okay, and then in quadrant 3, we would have, what, if we start at pi and we go, and we are going to travel a little more than pi, so that would be 1 more, so that would be 5 pi over 4. Once again, remember the numerator is 1 more than pi, which was 4 pi over 4, so 5 pi over 4. And then we have, for quadrant 4, let me draw this as best as I can. For this angle, the way we find this is you can, see, we know it's over 4. You can double 4 and subtract 1. So that would be 8 minus 1. That would be 7 pi over 4. So let's see our angles. I didn't write this. 5 pi over 4 and 7 pi over 4. So those are 4 new angles that we have. If you notice, what they have in common is they're all over 4. Right? Quadrant 1, 2, 3, and 4. So let's look at each one of them and look at their reference angles. So if we start at pi over 4, right, this has a reference angle of pi over 4. Right, if we go over to quadrant 2 at 3 pi over 4, we start at pi, and we move backwards, but still the distance is pi over 4. 5 pi over 4 from pi. It's all reflected across the x and y axis. And then finally, 7 pi over 4, you start at 0 or 2 pi, the positive x-axis, and that still is pi over 4. All of them have the same reference angle. Let's see, pi over 4, pi over 4. You can kind of see, they reflect, but they all have something in common, 4 new angles. And if you see them listed, all of them have the common denominator of pi over 4, so the reference angle is pi over 4. Okay, finally, let's look at our 4 remaining angles that we want to talk about, which is the 60-degree angle, which is pi over 3. Okay, so in our first quadrant, pi over 3 located right here. This is pi over 3. Okay, that's our first quadrant angle. So if we move to quadrant 2, remember we go to pi, which is at 180 degrees. If we wrote it in terms of the denominator, that's the same thing as 3 pi over 3. That equals pi. So for quadrant 2, remember how we do this. We do it in terms of the reference angle. We go backwards there. And the numerator is 1 less than the denominator, so that would be 2 pi over 3, since you're subtracting a pi over 3 away. And then for quadrant 3, let's see if we go to 3 pi over 3 and we add an additional pi over 3, that gives us 1 more on top, so that would be 4 pi over 3. And then for quadrant 4, let's see, remember how we find this. It's over 3, we know that. You double the 3 and get 6, take away 1. 5 pi over 3. These are our 4 angles. Okay, so let's look at the reference angles. So for pi over 3, right, we have a reference angle of pi over 3. That's always our first quadrant angle, is always the reference angle. And since everything is over 3, then we know the reference angle is pi over 3. It's just a quick way to think about it. So 4 pi over 3, that's pi over 3. And same thing for our fourth quadrant, pi over 3. So the 4 angles we've talked about is pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. They all have in common, they're over 3, and their reference angle is pi over 3. It's just whatever the denominator is, that's a little hint. And if it helps to see them shaded, we have pi over 3. You start at pi and you go backwards. There's that reference angle. These are our reference angles. So we've covered the general angles, for each of them they have common 4 angles for each quadrant. We've covered most all of these, and hopefully this is a help for you. When I give you an angle, can you place it somewhere on the unit circle? Hopefully this helps.